Hi everyone, welcome back to Three Inquisitive Kids. In this video, we will be starting our section on remainders. So before we start this lesson, keep in mind that if this is new to you, this is number sense, remember. So we have another playlist or lesson actually, called Working with Remainders, and that's kind of the same thing as this, but a more basic version. That's when we first start getting to know the concepts and all of that. All right, and then and also for number sense, you really need to get hold of your divisibility rules. Divisibility rules is kind of knowing which numbers are divisible by what other numbers. And we also have many other number sense videos like factors and multiples, so on. So some of them will be in the same playlist, the 5th grade word problem skills playlist, just like this one. Or it might be a 4th grade level one, so I put it in separate playlist, and I will give you the links to those separate videos in the description down below. So you can feel free to go down there whenever you want, take a look and come back. So here is our first problem on remainders. What is a unit digit sum of 1 to the 2007th power plus 2 to the 2007th power plus 3 to the 2007th power, so on until 2006 to the 2007th power? First, seeing huge numbers like this, we know that the solution to the problem probably isn't gonna actually calculate 2006 to the 2007th power and then add all those digits up. That would be, close to impossible. So there must be some sort of pattern. And when I work with patterns, the first thing I like to do is create a table. So I am going to make a horizontal table like this. I prefer them. And I'm going to make it right here. So up here is going to be the expression, and down here is going to be unit digit. Is going to be unit digit. Oh, okay. Unit digit. All right. So first we have 1 to the 2007th power. Well, 1 is easy. It's just multiple ones multiplied together, and it's 2007 ones being multiplied together. That still equals 1. All right, now let's move on to 2 to the 2007th power. Well, 2 to the 2007th power, it's going to have a pattern of its own. So 2 is 2, 4, 8, 16, 32, and we're back to 2 again in the unit digit. So it has 4 rotating digits. If we divide 2007 by 4, we get 501 with a remainder of 3. So we don't even need to look at this 501 right here. We just have to look at the 3. So we count to the third term that's in every rotation, 1, 2, 3, and that's going to be 8. So the units digit of 2 to the 2007th power is 8. Let's move on to 3 to the 2007th power. Just like 2, 3 has a distinct pattern as well. We just have to figure it out. So 3, 9, 27, 81, and then back to 243, which has a units digit of 3. Meaning that for 3, there's a rotating pattern as well. Also 4. We already know that 2007 divided by 4 has a remainder of 3. So we look at the third term of that sequence, 1, 2, 3, and that's 27. And 27, we're not going to write 27 because it's just asking for one unit digit, so that would be 7. 4 to the 2007 power. Okay, just like 2 and 3, there is a pattern to this as well. Maybe a little different. 4, 16, and back to 64. So it's 4, 6, 4, 6. In 2007, it's an odd number, meaning it's going to have a remainder of 1 when divided by 2. So this would be 4. Now let's look at 5 to the 2007th power. 5 to the 2007th power, that's fairly simple because it goes 5, 25, 125, so on. So it always has a units digit of 5. Now let's look at 6 to the 2007 power. So far over in this table, we don't have any repetition yet. 6, 36, 216, all sixes. What about 7 to the 2007th power? 7, 49, 343, and then, alright, we just know that this has a unit digit of 1. There's no need to go any further. And then back to 7. So, it has a rotation of 4 terms. And again, that's going to have a remainder of 3 when divided by 2007. And that would be 3. Now I'm just going to start omitting that 2007, alright? Just so we have enough space. So what about 8? 8, and I know this is taking a long time, but believe me, this is worth it. 8, and then we have 64, then we have, so 8, 64, and then 2, and then 6, and then 8 again. So again, third term, number 2. So it seems like we're over here, there's no repetition yet because we're just getting every single digit from 1 to 9. And the only 2 digits we're missing is, 2 and 9. 0 and 9. So let's look at 9 right here. So 9 is 981 and back to 9 again. And again, 2007 is an odd number, so it's gonna have a remainder of 1. So this is 9. So let's look at 10. Well, 10 is always going to have a unit digit of 0. So if it's 11, back to start rotation, it's going to end with 1 every single time. So now let's look at this entire pattern. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a rotation of 10. So to find out 2007 divided by 10, well, 2007 is fairly close to 2000, which equals 200 times 10. And we're going to have a remainder of 7. Now, we take that remainder and we count to 7 of this series. So 1, 2, 3, 4, 5, 6, 7. So the final answer would be 3.